So today we are going to be talking about finding the present value of a deferred annuity. So let's read the question and see what we can do here. The estimated return on investment is $5,000 per year at the end of years 4, 5, and 6. If the return is 8% annually, what is the present value of these cash flows? So first, I'm going to do a graphical representation as to what is happening here. So basically, at year 0 right now is what we would like to know, essentially. And then year 1, we made nothing. Year 2, we made nothing. Year 3, we made nothing. At the end of years 4, 5, and 6, though, we made, what was it, $5,000. So 5,000 here, 5,000 there, and 5,000 there is the projected return on this investment. So let's talk about it. Well, first of all, we need to figure out the present value here, right? What is the present value right before? And we're going to call this PV1. And then we also want to know, okay, great, if we knew this number, we'd be able to find PV2, right? And why is that? It's because between these first 3 years, time is passing, right? Time is, things are accumulating. However, there's no actual return on investment made until year 4, right? And that's why this is called a deferred annuity, because we have to wait the first 3 years and then actually slightly more than that, because then we have to wait until the end of year 4, 5, and 6 to actually see any return on our investment. So first we need to calculate the present value at year 3, which I suppose we could refer to as the future value in 3 years. However, we're still going to use the present value formula. We're first going to pretend as though the here and now is actually 3 years from now, technically. So we're going to assume that let's say it wasn't a deferred one, deferred annuity at all, and right here is where we were today. So let's figure out what that is first off. So PV1 is going to be equal to A, the annuity value, which is $5,000. That's how much we'll be getting for the next 3 years. Every year for the next 3 years after this. Then we have times 1 minus 1 plus I, the interest rate. The interest rate is 8% annually, so 1.08, and then to the power of negative n1. And N1 in this case is going to be 3 because we're expecting 3 years, year 4, year 5, and year 6. So that's 3 years of these returns. So to the power of negative 3. And that's all over I, like that. And then I'm going to just calculate that. So 1.08 to the power of negative 3, hit equals. And then 1 minus that number, hit equals, divided by 0.08, hit equals, and last but not least, multiply by 5,000, hit equals. Okay, so that gets me $12,885.48. So therefore, that's kind of our break even. Basically, if let's say right now was actually 3 years from now, in order to make this investment happen, in order to get these returns according to the information we know, we would have to right now today, well, aka at year 3, put in $12,885.48 in order to get these returns. Now, because the returns are delayed, sure, we're going to get $15,000 of returns, right? 5,000 3 times, but the value we would have to do since it's earlier is going to be less money. So PV2, therefore, is going to be even less money. What if we, because essentially at this point, what we need to know is what is the equivalent of paying $12,885.48 3 years from now, right? What is the equivalent of that if we just put in the money today? If we do it today, 3 years before, it's going to end up being less money. So that brings us to finding PV2, which is going to be equal to PV1, which is $12,885.48 over 1 plus I to the power of n2. So that's going to be 1.08 to the power of n2. Now, n2 is actually also 3, but for a different reason. It's because between year 0 right now and year 3, there's a 3-year gap there. So that's why that one is going to be 3 as well. They generally won't be the same, but in this case, they are. So I'm going to do that. $12,885.48 divided by 1.08 to the power of 3, and that is equal to a bit less, $10,228.91. So therefore, if we put in $10,228.91 today, then at the end of year 4, we'll get $5,000. End of year 5, we'll get $5,000. End of year 6, we'll get $5,000, right? So because we set aside this money and we waited, we ended up getting a return on our investment, right? Because we end up getting a lot more, or at least about $4,800-ish more than what we originally paid due to this waiting time. All right, as always, if you have any questions about any of that, feel free to put those in the comment section, and we'll see you for the next one.